Yep, we can start.
So yeah, guys, everyone, welcome to the space mission series, the new series for the semester. And yeah, today we'll be having the first talk on Parker Solar Probe by Himanshu and Ritika of BSMS 2021. So yeah, you guys can start now.
Okay, fine. So hello everyone. Hope you all are safe and sound and enjoying your weekend. Okay. I hope my this presentation will bring more joy to your life. And please, I want to talk to all of you, and I don't want you to text your friend that what is he talking about. I'm not understanding a word. If you don't understand, you can say on the presentation. Okay, no problem. Okay, so let's start about that. So my presentation, our presentation is on Parker Solar Probe when we met our grandpa. Okay. So what are we going to have in this presentation? After this presentation, you will be able to know what makes this mission so special. When was Parker Solar Probe made? How was Parker Solar Probe made? Why are such mission needed? In short, we are going to answer all the WH questions which you have regarding Parker Solar Probe. Okay, so today Ritika and I from BSMS 2021 are presenting this to you. Okay, so let me start with a basic imagination. All of you have a dream to become space scientist, I suppose. So I give you a chance. Okay, you have a chance. Just imagine. Okay, you have a chance to become a space scientist at NASA. Okay, and you are one of the best minds of the world. Okay, you can raise your collar to that, but that will not be nice. Okay. Now your first mission is the mission to reach to the sun. NASA decided to go to sun, and you have been assigned the mission to go to sun. So let us discuss something that what do you think? What are the problems in going to the sun?
The distance probably.
Okay, any other?
The temperature.
Yeah, that is also right. Anyone else?
And lack of means to the transportation.
Yeah. See, the first of all problem is the budget. Okay, you can't build a spacecraft for free. So you have to ask your senior for a budget. The first problem is budget. Okay, so the solar probe had a budget of $1.5 billion. Okay. And then the second problem which you have is you have to have a deadline because no one finishes the work before the deadline. So you ask a deadline from your senior, which for the solar probe was 12th August of 2018. That was the launching date of the solar probe. So that is the two programs which I have. So you draw a basic plan. Okay, you are the scientist, so you draw a basic plan that we will fly by Venus in such a way that we get into the sun. So first of all, let me define what is flyby mean. Flyby means that you do not get into the planet or you do not start orbiting a planet. It just means that you just approach the planet, use its gravity, and go past to another planet which you want to. So that is a basic meaning of a flyby. So the plan was decided that the spacecraft will go 8 flybys by Venus, and then it will enter the layers of the sun. Okay, so next question is that why Venus? Why not Mercury?
Well, the gravitation of Mercury is not enough, and also Mercury is already so close to the sun. So if you can send something there, then why not just send it directly to the sun? Venus is closer to the Earth.
Yeah. You are right. The first of all, the Mercury is difficult to observe, so you cannot launch a spacecraft directly to Mercury. In the night sky, Mercury is very difficult to observe, whereas Venus comparatively is much easier to observe. Okay, so that is the primary reason when they why did they do not choose Mercury. And another reason is if you have to reach Mercury, then also you have to take the flyby from Venus. So there is no point in having flyby from Venus earlier and then reaching Mercury. Okay, and the spacecraft will have to be in more temperature region as in Mercury as compared to the Venus. When you are orbiting Venus, you are in a less temperature region. But while you are orbiting Mercury, then you are in more temperature prone region. So that is why the scientists choose Venus instead of Mercury. So the plan was simple that after 7 flybys for Venus, the spacecraft will enter. the inner layer of the sun, which is the corona layer. Okay. So what is the issue? Isn't that simple? I know that is not simple at all. So in the earlier classes, when you were kids and when I was kid, our teachers taught the sun's temperature is very comparatively very high. No metal can stand that temperature. The strongest metal which is present on Earth is tungsten, which has a melting point of 3410 degrees Celsius. And the layer which we are talking about has a temperature of 1 lakh degrees Celsius. This one layer, the coronal layer of the sun. And so I think anybody has a solution to it. How can this stand to do this very high temperature? Any guess? I think wild guess that this can work, this cannot. Okay, so I think nobody has that. No
Use
problem.
of sun
So that what
coolant.
happens. You can't build a cooler such that you can stand
No,
to
no,
1 lakh degrees.
I was saying using of a coolant mechanism in the spacecraft.
Yeah, that can work, but what will be the coolant mechanism?
That's to be thought of.
Okay, so that is the point when your senior tell you that this mission is not so easy and you have to struggle for making such a spacecraft. And you think that you are just young and you cannot think so hard. So you grow sad like that. Okay, so and then you close your eyes and you remember a very famous quote of a very famous man, our ISRO scientist, APJ Abdul Kalam, this one. That history has proven those who dare to imagine the impossible are the ones who break all the human limitations. So you say your senior that, okay, I will try, and you get on with the mission. So let's see how it's went on. Let the magic begin. So first of all, whenever there is a work, you need to have some history of the work. Okay, so you have seen that what are the failures, why were they fail, and what are your chances of getting success. So solar probe history dates from 1958, when a group of scientists proposed that a solar probe to pass inside the orbit of the Mercury, and it can easily study the magnetic field and particle speed of the suns. Okay, so that was the solar probe major origination in 1958. And in 1990, the NASA proposed 3 missions, which was the Solar Orbiter, the Pluto and the Kuiper, and the European Space Orbiter. These 3 missions were proposed to go to the Sun and orbit them, but these failed due to all the political reasons and the economical reasons and all. So in 2010, the scientists of that era discarded the theory of 1958. They said that if we use Venus, we can make a cheap solar craft and we can easily orbit the sun. Okay, so using multiple gravitational assist of Venus, it will be easier to build a spacecraft instead of Mercury. This was discovered in the 2010s and all. So you get a very good history that this mission has been sometimes tried earlier. So your reaction was just like this one meme. I just showed you it. Wait. Okay, fine. Now that's come the next part where you have to research that what is the possible, what is not possible. So that is the part of research. Okay, so you can see the scientist. He is looking into the telescope. What is the meaning of touching the sun? Can anyone tell me what is the meaning of touching the sun? Does it mean to touch the inner core of the sun, or does it mean to touch only the outer layer?
Outer layer.
Correct. The inner core, you cannot go deep into it, right? So it means to touch the outermost layer, and outermost layer of the sun is corona. And don't stare at me. I am not talking about this one corona. Nobody wants to reach this. Okay. I am talking about this one. Okay, then you start looking for books, and you want to know all the features of this layer so that you can easily enter this layer. And so in 1924, scientist G.F. Maraldi founded the layer corona of the sun, and it was coined the name in 1809. And I don't know why this virus was named after it, but yeah, in 1809, French astronomer Ferrer coined the term corona for the sun outermost layer. What is special in this sun outermost layer? That it has the temperature higher than the sun's core. It can have a temperature to 1 to 3 million degree Kelvin. And what you can get information is that you can see the magnetic flux, magnetic field lines, and the solar winds very clearly in this layer. Like you can see in the photograph below, there are you can see the magnetic field lines. These are clearly very much visible. And this one photo here, you can see that how the field lines are clearly visible in this layer. Because what happens here is that the particles are much heated up, and so their path of magnetic field becomes clearly visible. So now my friend Ritika, she will talk you about all the facts and steps to be followed for making the spacecraft.
Wait,
Okay.
so that
Yeah.
magnetic field lines, is it like have you spread some iron filings on a magnet and just arrange in the same direction as magnetic field?
I think the particles which are outside the sun's layer, they get so heated up that they are part of revolving the sun in its magnetic field. That becomes clearly visible.
Yeah, okay, but I think it's more because they get ionized and they become a dipole.
Yeah, that can be a probable reason.
Okay. So let me acquaint you all with some of the basic facts of Parker's solar probe. Next slide. Parker's solar probe, humanity's first visit to a star. NASA's historic Parker Solar Probe mission is revolutionizing our understanding of the sun, where changing conditions can propagate out into the solar system, affecting Earth and other worlds. Parker's solar probe travels through the sun's atmosphere closer to the surface than any spacecraft before it, facing brutal heat and radiation conditions to provide humanity with the closest ever observations of a star. The Parker Solar Probe is a NASA space probe launched in 2018 with the mission of making observations of the outer corona of the sun. It will approach to within 9.86 solar radii, that is 6.9 million kilometer from the center of the sun. As Himanshu said, touching the sun does not mean penetrating to the core. So by 2025, it will travel at closest approach as fast as 690,000 km per hour, or you can say about 0.064% of the speed of light. The project was announced in the fiscal 2009 budget year. Johns Hopkins University Applied Physics Laboratory designed and built the spacecraft, which was launched on 12th of August 2018. It became the first NASA spacecraft named after a living person, honoring physicist Eugene Newman Parker, professor emeritus at the University of Chicago. On 29th of October 2018, the spacecraft became the closest ever artificial object to the sun. The previous record, which was 42.73 million kilometers, approx 26.55 million miles from the sun's surface, was set by the Helios 2 spacecraft in April 1976. As of its perihelion, 21st of November 2021, the Parker Solar Probe's closest approach is 8.5 million kilometers, that is 5.3 million miles. This will be surpassed after each of the two remaining flybys of Venus. Next slide. Okay, so let's move to the journey to the sun. As you can see, launch date August 12th, 2018, launch site Cape Canaveral Air Force Station, Florida, launch vehicle Delta IV Heavy with upper stage. Its trajectory requires high launch energy. So the probe was launched on a Delta IV Heavy class launch vehicle and an upper stage based on the Star 48 BV solid rocket motor. Interplanetary gravity assists will provide further deceleration relative to its heliocentric orbit, which will result in a heliocentric speed record at perihelion. In order to unlock the mysteries of the Sun's atmosphere, Parker's solar probe uses gravity of Venus during 7 flybys over nearly 7 years to gradually bring its orbit closer to the Sun. The spacecraft will fly through the Sun's atmosphere as close as 3.8 million miles to our star's surface, well within the orbit of Mercury and more than 7 times closer than any spacecraft has come before. You all must be knowing that the Earth's average distance to the Sun is 93 million miles. Flying into the outermost part of the Sun's atmosphere, known as the corona, for the first time, Parker's solar probe employs a combination of in situ measurements and imaging to revolutionize our understanding of the corona and expand our knowledge of the origin and evolution of the solar wind. It also makes critical contributions to our ability to forecast changes in Earth's space environment that affect life and technology on Earth. Next slide. The near-Sun radiation environment is predicted to cause spacecraft charging effects, radiation damage in materials and electronics, and communication interruptions. So the orbit will be highly elliptical with short time spent near the Sun. As the probe passes around the Sun, it will achieve a velocity as high as 200 km per second, that is 120 miles per second, which will temporarily make it the fastest human-made object, almost 3 times as fast as the previous record holder Helios 2. Like every object in an orbit, due to the gravity, the spacecraft will accelerate as it nears the perihelion, then slow down again afterward until it reaches its aphelion. Next slide. Extreme exploration. What actually is so unique about this probe? Parker's solar probe performs its scientific investigations in a hazardous region of intense heat and solar radiation. The spacecraft will fly close enough to the Sun to watch the solar wind speed up from subsonic to supersonic, and it will fly through the birthplace of the highest energy solar particles. Do any of you have any idea what specialty makes it to tolerate such harsh conditions? Any of you have any idea? Like what makes it tolerate such intense radiations and all?
You are all scientists at NASA. You have to have an idea. Come on.
Okay, I'll continue. To perform these unprecedented investigations, the spacecraft and instruments are protected from the Sun's heat by a 4.5-inch thick, that is 11.43 centimeter, carbon composite shield, which needs to withstand temperature outside the spacecraft that reach nearly 2500 Fahrenheit or 1377 degrees Celsius. There is a white reflective alumina surface layer that minimizes absorption. The spacecraft systems and scientific instruments are located in the central portion of the shield's shadow, where direct radiation from the Sun is fully blocked. If the shield were not between the spacecraft and the Sun, the probe would be damaged and become inoperative within tens of seconds. As radio communication with Earth will take about 8 minutes in each direction, the Parker Solar Probe will have to act autonomously and rapidly to protect itself. This will be done using 4 light sensors to detect the first traces of direct sunlight coming from the shield, which limits and engage movements from reaction wheels to reposition the spacecraft within the shadow again. The primary power for the mission is a dual system of solar panels, or you can say photovoltaic arrays. A primary photovoltaic array used for the portion of the mission outside is retracted behind the shadow shield during the close approach to the Sun, and a much smaller secondary array powers the spacecraft through closest approach. This secondary array uses pumped fluid cooling to maintain operating temperature of the solar panels and instrumentation. Parker's solar probe carries 4 instrument suites designed to study magnetic fields, plasma, and energetic particles and image the solar wind. So the question arises here, what is the need to plan this mission? What is the need for this spacecraft?
You need to see the magnetic flux of the sun, the magnetic field, and whatever is happening in there, because we have not yet seen it.
Yeah, correct.
So,
So-
okay, 1 second. What you will get after seeing those magnetic field?
Well, for one thing, those things are extremely dangerous. You can, if you don't know how to predict them, they can just destroy the atmosphere, and we will
Yeah.
never know this.
Correct. It can help for our next space exploration and then find a new home, because if you know the sun, you can predict the energy and much better, right?
Yes,
Yeah.
or you can make a telescope as big as the sun.
Yeah, correct.
So this is all done to study the sun and the solar wind. So before moving further, let me tell you what is this solar wind. The solar wind is a stream of charged particles released from the upper atmosphere of the sun called the corona. Its particles can't escape the sun's gravity because of their high energy resulting from the high temperature of the corona. Next slide, please. The question that follows up here is, why do we study the sun and the solar wind? There are several reasons to this. If any of you wants to answer this, why do we study sun and the solar wind?
Well, we could use the energy of the solar wind. We are just using the energy of light from the sun, but we could also use that energy.
Yeah.
Yes.
So let me tell all the reasons here. So the sun is the only star we can study up close, right? By studying this star we live with, we learn more about stars throughout the universe. The sun is a source of light and heat for life on Earth. The more we know about it, the more we can understand how life on Earth developed. The sun also affects Earth in less familiar ways. It is the source of the solar wind, which I said is a flow of ionized gases from the sun that streams past Earth at speeds of more than 500 km per second, or a million miles per hour. Disturbances in the solar wind shake Earth's magnetic field and pump energy into the radiation belts, part of a set of changes in near-Earth space known as space weather. Space weather can change the orbits of satellites, shorten their lifetimes, or interfere with onboard electronics. The more we learn about what causes space weather and how to predict it, the more we can protect the satellites we depend on. The solar wind also fills up much of the solar system, dominating the space environment far past Earth. As we send spacecraft and astronauts further and further from home, we must understand this space environment just as early seafarers needed to understand the ocean. So now, as we are aware of why and the main plan, now let us discuss how will the probe revolve around the sun and at what date we can expect this mission to be completed. Next slide, please. You can see the image taken by the Parker Solar Probe during its second Venus flyby. So, operational history. Launch occurred on 12th of August 2018. The spacecraft operated nominally after launching. During its first week in space, it deployed its high-gain antenna, magnetometer boom, and electric field antennas. The spacecraft performed its first scheduled trajectory correction on 20th August 2018, while it was 8.8 million kilometers from Earth and traveling at 63,569 kilometers per hour. Instrument activation and testing began in early September 2018. On 9th of September 2018, the two WISPR telescopic cameras performed a successful flight light test, transmitting wide-angle images of the background sky towards the galactic center. The probe successfully performed the first of the 7 planned Venus flybys on 3rd of October 2018, where it came within about 2,400 kilometers (approx 1,500 miles) of Venus, in order to reduce the probe's speed and orbit closer to the Sun. The first scientific observations were transmitted in December 2018. NASA announced that on 19th of January 2019, the Parker Solar Probe reached its first perihelion, thus completing its first full orbit. On 12th of November 2019, the data from the first 2 flybys of the Sun, that is from 31st of October to 12th of November 2018 and 30th of March to 19th of April 2019, was released to the public. On 15th of September 2020, data from the 4th orbit around the Sun, including its first 2 Venus flybys, was released to the public. On 14th of December 2021, data was released to the public from probe's first plunge into the solar corona during its April 2021 perihelion. Next slide. Let's look at the timeline and get some idea. Sure. Okay. So 3rd of October 2018, Venus flyby 1. 26th of December 2019, Venus flyby 2. 11th of July 2020, Venus flyby 3. 26th of February 2021, Venus flyby 4. So you can see today we completed a year to this Venus flyby 4. 29th of April 2021, perihelion 8. Over to you, Himanshu.
Yeah, so this perihelion 8th is the point where it enters the coronal layer of the Sun.
I think you're breaking, Himanshu.
I don't know.
No,
Now it's okay.
sound is fine. Like I think there's some issue with your connection. Yeah, you can continue, I guess.
Yeah, so now Ritika has told you all the facts and how it will work, what is the plan, and now let me take you to back to the story. And then the day came. Okay, now you are on the eve of August 12, 2018. Okay, so you are ready. You are good to go for launch. Everyone ready? System
Yes.
checked. Okay. Get ready to go for launch. So there the spacecraft is being launched. Okay, so Ritika told in her information. Can anyone recall what was the launching pad?
Launching vehicle. Anyone?
Launching vehicle. Okay, fine, no problem. It was United Nations Launch Alliance Delta 4 heavyweight launching vehicle at Florida station of launching. Okay, so that is the launching vehicle of Parker Solar Probe. And yeah, spacecraft reached the sun's layer and it's captured the images, and you can see how it feels like when it has reached the sun's layer. Like this image, you can see that sun is putting a lot of heat, but the spacecraft is not getting burned. Now I will show you the images which the spacecraft will send us, and that will prove that it has entered the sun. Like this.
I have a question. You said that metals burn at that temperature. Metals melt at that
Yeah,
temperature.
correct.
Then how
Yeah,
does this carbon shell protect them?
The outermost layer of this has white coating, so white just reflects all the radiation. Okay, so that is why and then there is the carbon shell. So if some radiation enter also, then the carbon shell protects the spacecraft.
Okay.
And this is the image of the magnetic field line which it has recorded while revolving inside the sun. Magnetic field line and the solar winds, you can clearly see, I think that it is visible. And then you have the image of the earth which he has sent from there. And then I have the image of that only again. You can sense the solar wind and the magnetic field lines, which the spacecraft has captured for all of us. So congratulations, you have successfully completed the mission and you deserve an applause. So I have two songs. If anyone has a good throat today, he can sing. Otherwise, you can just read the lyrics. I have written one in English and one in Hindi. Anyone has a good throat today, or everyone has cold cough?
Is Sivakami there?
Yeah, I'm here.
Anurag,
I haven't seen this song before, so how can I sing? Can I read it or something?
Yeah, just read.
we have no problem with anything. You can do it.
Okay, I will read the English one. I don't know that Hindi one. Okay, I will read the English one. It will be very worst that you have to like cope up with that. Okay.
No problem, no problem. You can go anyways.
Okay. Sometimes it can seem like a merciless dream, and I'm falling with nothing to hold. Sometimes I get flustered and beaten and blistered, abandoned outside in the cold. But I'm gonna win, I'm gonna try, and I never lose, and I never die. You have seen me before, you will see me again, and I'll never give up, and I will give in. Thank you. I'm gonna do this.
Great, yeah. Great.
Okay.
Anurag, is he here or not?
No, I don't think. Move ahead.
No problem, okay, fine. So you might be wondering, what is the present status of the solar probe? What is the solar probe doing now? How can we locate that if you got a good telescope there? So Parker solar probe is currently in the constellation Ascaris, okay, and a declination of 7 degrees. And the sensation is 23 hours and visibility right now. You can view it from above the horizon of Greenwich, United Kingdom, and it is visible looking in the east-south direction at the altitude of 12 degrees above the horizon. The Parker solar probe is currently at 157 million kilometers, equivalent to 1 astronomical unit. Light takes 8 minutes and 44 seconds to travel from Parker solar probe to us. So that is the image which the scientists have captured of the Parker solar probe where it is right now.
Wait,
And
8 minutes, how
it
much
will be
seconds?
what?
8 minutes, how much seconds?
I did not get you. Can you speak again?
8 minutes and how much seconds?
Previous slide.
Yeah, 8 minutes and 44. 8 minutes and 44 seconds.
Why is that? Because it takes 8 minutes and 20 something seconds for light to reach from the sun. So why does it take more time
It
for
is
light
not
to...
at it is revolving in sun. It is orbiting Venus and sun. It is in an elliptical orbit. It is not accurately at the sun's position.
Okay.
So it will be not fair to not mention the real heroes. I have given all the credit to you all, but I think I should mention who all have made it. Okay, I made this slide last night also because I thought I should give them credit as well. So that was the team of NASA. Johnson Smith led the team, and there was many more. You can see on the screen. And this was the team from that University of Applied Physics Laboratory, which did the management of this spacecraft. And then that is the team's photo you can see. And that is the references we have used. And now I will share some memes. I have made them by my understanding, and not to offense, they are nothing inoffensive as well. So that is a teacher. You can read. Fair enough, right? Now the next one. In English, it means you should also talk to me. Now the next one. All the low budget orbiting Earth satellite to high budget orbiting Earth satellite. Now, because solar probe has reached the sun, so every low budget satellite which is orbiting Earth can troll the high budget satellite saying, okay, so that is the point. If you don't understand it, it means like you have also not done anything special. You are also revolving Earth, and I am also revolving Earth. So thank you, and I think you had a nice time with us. So 45 minutes, it was not a waste. Was it nice, and you all enjoyed it?
Yeah, it was really nice. We enjoyed it completely. Yeah,
Yes,
it was.
Himanshu, it was a good presentation.
Yeah, Himanshu, your memes ideas were very good, man. But I missed cricket in it.
Thank you. Oh, I will add. I will add. Next time I will add.
All right. Do you guys have any questions about the like content about
Yeah.
the Parker Solar Probe? You can ask. Okay. If not, then I think we can conclude.
Yeah.
Yeah, I think we can conclude. It was a good presentation.
Thank you.
What?
Shall I stop sharing now?
Yeah, I'll stop recording now. So everyone, look forward to the next talk. And yeah, again,
Yeah.
thanks, Himanshu.
And like guys, 2021 batch, these series are especially for like the new upcoming, like the new batches every year, like we kind of conduct this. So yeah, like there are so many like other slots left. So I would appreciate if you guys like come forward and like give such amazing talks like Himanshu and Ritika gave today. And it was like full of like information plus entertainment. So it was very cool. So yeah.
Yeah, you can encourage your like friends also to come.
Yeah.
Yes. Yeah. Anyone to
Cool. Cool, then we can stop recording and we can leave, I guess.
Yeah.